Hello and welcome back. We're going to start with lesson 93. This is on page 484 if you're following along in the Saxon textbook. It's called Classifying Triangles. So in this one, we're going to look at triangles based on classification of sides as well as angles. Let's dive into the sides though a little bit. You can look at different characteristics of triangles based on the lengths of their sides. For example, here's an equilateral triangle. This equilateral triangle shows that each of those sides is the same length. That's what those little tick marks mean on the sides of that triangle. So that triangle has 3 sides of equal length. So that's considered an equilateral triangle. That's classified by sides. So if we're strictly looking at the sides of this triangle and they're all the same length, the only way they would be able to be connected is if they're all the same length in this case, to be an equilateral triangle. All right, looking at an isosceles triangle. An isosceles triangle has 2 sides of equal length. And that's considered like this, for example, this side and this side are the same length. This side right here is a different length. That side it looks to be shorter. These 2 sides are longer. So this side and this side are longer, but they're equal in length to each other. And because it has 2 sides of equal length, we would call it an isosceles triangle. If it has 3 sides of unequal length, it's considered a scalene triangle. So all 3 sides are unequal in length. So this side is a different length than this side and this side. All 3 sides have different lengths, and that would be considered a scalene triangle. We can also classify triangles by angles. So you could have the same triangles, but just looking at the angles, not looking at the lengths of their sides. If we're just looking at angles, you could have an acute triangle. If you guys remember up here, it was an equilateral triangle. Well, down here, we're going to name it differently based on it having all acute angles. What are acute angles? Well, we learned about what acute angles were way back in lesson 28. So if you want to review what acute angles are, that was in lesson 28, if you want to go back to that. But the acute triangle is basically just looking at all of those angles, and an acute angle here, an acute angle here, an acute angle here means that all of them had acute angles, and that's an acute triangle. So you can see that this equilateral triangle is also called an acute triangle. But we're only looking at the angles down here. Up here, we're looking at the sides. So an equilateral triangle that has 3 equal sides also has 3 equal angles. And each one of those angles has to be less. So that angle and that angle and that angle, all 3 angles, all 3 of these angles have to be less than 90 degrees. Okay? So that's an acute triangle. Then there's also a right triangle. Well, what does that need? It needs 1 right angle. That's all it needs. So if you can see right here, this symbol represents a right angle. So that has 1 right angle, and that's it. This could also be considered what other triangle? Equilateral, isosceles, or scalene. If you look at it, this one right here pretty clearly could be, you can see that it also has these 2 sides being equal. So it could be a representative of an isosceles triangle if you wanted to classify it by sides. But down here, we're classifying them as classifying triangles with angles. So that's what you would need to look at. Just one right angle. That's it. Just one right angle. It's a right triangle. Okay. If you're classifying it and it has, in this case, one obtuse angle, then it's an obtuse triangle. So you can see here, this angle right here is greater than 90 degrees. It has to be greater than. So this angle would be the obtuse angle. This one up here was less than 90 degrees, or sorry, it had to be exactly 90 degrees. It had to equal, needed one 90-degree angle. This one has to be greater than, and one of these had to be less than 90 degrees, or all of them did. So all or less, this one is just 1 equals 90, and this one is just 1 is greater than 90. And it's an obtuse triangle. And you can see up here, this scalene triangle, based on its sides, might also be considered an obtuse triangle. If you looked at this angle right here, you could also call it an obtuse triangle. And that doesn't always work out like that, but usually it will. So what do you think this one is? If we're looking at sides here, so based on sides, on the previous slide I was using orange to represent the sides. So would it be an equilateral triangle, an isosceles triangle, or a scalene triangle based on its sides? It's an isosceles triangle. And let's spell this right for a second. So you can see this one's an isosceles triangle because it has a tick mark there, and there would represent this side being the same length as this side. And this one is a different length. Okay, so it has two equal sides of equal length, two equal sides, isosceles triangle. That's if we're looking at the sides to classify this. What about this one? What do you think that one is? That's a scalene triangle. So in this one, you can see that this side is shorter than this side, and this side is the longest of the three probably. So you can see none of the sides equal each other. So that would be classified three sides of unequal length makes a scalene triangle. And what about this last one? What do you think it is? This one is an equilateral triangle because you can see here, this side equals this side equals this side. All three sides equal each other. Okay, looking at this, what do you think this one is? Now we're classifying these as angles using angles as we had done before. If we're classifying this as an angle, what would this one represent? This one would be a right triangle. You can see clearly it's got an angle here. It's got one angle that represents that. If you go back here, it has to have one right angle to be classified a right triangle. So just one that's equal to 90 degrees. Right? What about this one? When you're looking at the angles, remember you're looking at the angles here, all the angles here. You need to refer to the angles. We're not looking at the sides anymore. We're just looking at the angles. So what would you classify this one if you're basing it on the angles? This would be acute, an acute triangle, because all three angles are less than 90. And that leaves this last one. If you look at it, you can see this angle will help you. These two look like they're acute, but this third one right here looks like it's greater than 90. So what would you classify it based on its angle? That's got one obtuse angle. Obtuse triangle. If you look back at the rule, one obtuse angle makes it an obtuse triangle. It has to have one that's greater than 90 degrees. Now let's try a few of these. So one side of an equilateral triangle measures 15 centimeters. What's the perimeter of the triangle? So if this side is 15 centimeters, that means in an equilateral triangle, three sides are of equal length. Equilateral triangle, all three sides are equal to each other. So if you're looking at this equilateral triangle, you know this side is also 15 then. You also know this side is 15. So that one's pretty simple. You just have to take 15 centimeters times 3. And what's the answer to that? 45 centimeters. That would be the perimeter of that triangle. If you have an equilateral triangle that's also an acute angle, is that true or false? An equilateral triangle, can it also be considered an acute triangle? So if you're classifying it as an equilateral triangle, you're looking at the sides. All the sides are the same. Can it also be classified an acute triangle? Well, let's look at that. What does it take to be an acute triangle? All acute angles. So since all of them are acute angles, that's what it would be requiring for an acute triangle. Let's look at these angles real quick. We've got this angle, and this angle. Now, are they small, smaller than 90, or are they larger than 90? If they're smaller than 90, then your answer to this question would be an equilateral triangle is also an acute triangle would be true. How about letter C? All acute triangles are equilateral triangles. True or false? So all acute triangles are equilateral triangles. Well, let's look at an example we had previously. Here's an acute triangle. Is that also an equilateral? This is acute because these are all less than 90. Now you have to determine, are all the sides the same? No. This acute triangle is not an equilateral triangle. So the answer to this one would be false. All acute triangles are not equilateral triangles. It would not work. How about this one? If you have two sides of a triangle that measure 3 inches and 4 inches. So one side is 3 inches and one side is 4 inches, and the perimeter is 10 inches. Well, let's see. What's 3 plus 4? Well, that equals 7. And then what's the 10 minus 7? That equals 3. So that means we have a side that's 3 inches, 4 inches, and 3 inches. What type of triangle is it? Let me just do a quick drawing of it. If one side is 3 inches, and another side is also 3 inches, and another side in this case would be 4 inches, it's supposed to be longer. Might not look like it, but in this case, this side is the same as this side, and this side is a different length. So what do you call that? If you're basing it on the sides of the triangle, you're looking at, in this case, it would be an isosceles. Okay, and then letter E, every right triangle is a scalene triangle. Is this true or false? Let's just draw a quick right triangle. And let's draw another one here just for posterity. All right, I've got that one and that one. Let me draw another one. Another right triangle. And this would be the right angle here. This would be the right angle here. This is the right angle on this one. Every right triangle is a scalene triangle. What does it take to be a right triangle again? Had to have one equal to 90 degrees. One angle equal to 90 degrees. So there's an angle in each one of those that has 90 degrees. What does it take to be a scalene triangle? To be a scalene triangle, all three sides had to be different, right? So this one, if you look at this one right here, I can see that this side is equal to this side, and this side is different. I can see that this side is probably different than this side, and it's probably different than this side, just like this one. This one also looks like this one is the shortest. But if you look at this one, every right triangle is a scalene triangle. This one actually would be considered what? Based on these two equal sides. When you go back and look at our parameters, or if it has two equal sides, it's an isosceles triangle. So you can see this right triangle that we created here is a scalene, but this one has two equal sides, which makes it an isosceles triangle. And this one has three different sides, which also makes it scalene. So is every right triangle a scalene? That would be false. They are not. Okay. Here's your quiz. Go ahead and work through those problems on your Go Formative. And if you have any questions, don't forget to write them down and then ask them during the daily discussion. We'll go over some of these things and we can review this stuff as we need to.